Hello everyone, welcome to the SAP 2000 course. Today we are going to cover basic course, lesson 6, support and release. Before we start the analysis, we have to tell SAP 2000 two things: how the structure is fixed to the ground at each end of members in the XYZ directions, whether they are allowed to move or rotate. Only when these are defined correctly will the model be stable and not produce warnings or strange jumping deformations. So let's begin today's lessons. First, open the model from Basic Course Lesson 5. We have two windows, left and right. Adjust the display size of both windows to a suitable view. The screen looks a bit messy right now, so let's first remove the previously displayed 200 x 200 section assignment. Click the window, go to Assign, clear display of assigns. Now all the colored section information is cleared. Do the same for the other window as well. Once that's done, we don't want to see the red, blue section or material colors for now. Press Ctrl+ W to open Display Options. Go to General Options. Under View by Colors of switch to Objects. The restores to original object color only. We don't need to see section or material colors right now. Click Apply to all windows. Click Apply. Then OK. By default, the frame objects are displayed in yellow. If you want to adjust the default object color, you can do it here under Options, Colors, Display. You could also change them to white if you prefer. For now, we will just keep them yellow. Next, we are going to set up the fixed supports. At the base, before we define the fixed supports, let's take a quick look at the local coordinates axis. In SAP 2000, every bin and columns has its own local direction system. SAP uses local 1, local 2, local 3 to represent the members' local axis. How do we display the local axis? Again, press Ctrl+ W. In the frame section of the dialog, turn on Local Axis. Now, in the 3D view, run in. You will see the local axis drawn on each member. Local 1 is red and runs along the length of the member. Local 2 is green. Local 3 is blue. Local 2 and Local 3 lie in the cross-section plane. For the wide flange edge-shaped section, Local 3 is usually the strong axis, and Local 2 is the weak axis. If we release N3, it means we allow free rotation about the strong axis. In contrast, the overall model uses the global axis X, Y, and Z. So when we define supports, we must distinguish clearly whether we are talking about the global axis or local axis. Now let's start fixing the current basis on the button level. First, reset the 3D view to a suitable size. Use the Windows selection with the mouse to select the button of joints. There should be 3 joints in total. Then go to the top menu, Assign Joints. Restraints. The first part of the dialog asks you to define the restraints in the joint local directions. This corresponds to the 6 degrees of freedom. Translations along the local 1, local 2, local 3 axis. Rotation about the local 1, 2, 3 axis. If we check all the 6 boxes, we get what we usually call a fixed support. If you don't want to tick each box one by one, you can use the shortcut buttons at the bottom. Fixed restraints. All 6 DOFs are restrained. Pinned. Translations restrained. Rotations free. This is a hinge support. Roller. Only one direction of translation is restrained. The others are free. Free. All degrees of freedom are free. In this example, we will set all 3 buttons joints at fixed support. So choose fixed restraints and apply. You will now see a fixed support symbol at all 3 base joints. Next, we will demonstrate end release at the members' ends. First, let's clean up the display again. We don't need to show the local access right now, so turn off the local access display. Now we want to see the end releases. Select the top story bin in the first span. We will use just this bin as an example. Go to Assign, Frame, Releases. Here you can release many types of internal actions, axial force, shear force, torsion, moment. On the right side, we see the frame partial fixed springs. This part is used to model semi-rigid connections, such as bottled connections or partial penetration welds at beam column joints. In this lesson, we won't use the partial fixed T springs yet. We will assume either fully fixed or fully released. For this example, let's release the N3 moment at the start ends. Then click Apply. Run in and you will see the hinge symbols at the left ends, indicating that those ends had been released. At the right end, we set the end point to release. Next, we are going to define a spring support. In reality, some column spaces are not perfect fixed. They have some flexibility. We can model that with a spring at the base joint. Select joint at the bottom of the column. Go to Assign, Joints, Springs. Under Spring Type, choose Simple. Under Spring Coordinate System, select Global. The entire here represents stiffness in each direction. For example, we will assign a stiffness of 5E6 in the Z direction. Click Apply. You will see a spring symbol at that joint with Z direction stiffness value shown. What does this mean? It means the joint can resist force in the direction, but still allows some displacement. The spring takes loads according to force equal to stiffness times displacement. After finishing the settings, let's check whether everything is correct. Press Ctrl plus W again, and in the display option turn on. Frame released, joint restraints, joint springs. Then click Apply. Now you can see the beam end has been released. The bottom joints are fixed, and this particular joint has a spring assigned. Now the settings are correct. The spring support, base support, and the end release are all properly defined. Up to this point, we've finished defining fixed support at the bottom, applying end release to the beam, adding an intermediate spring support. And we are also clarified the meaning of local and global access. That's all for today's lesson. If you enjoyed today's lessons, remember to share, subscribe, and turn on the notification bell. In next lesson, we will learn about loads and load combinations. See you in next class.